Good evening. Can you hear me? Yes. Okay. Uh, Last week we discussed basic parts of fluid mechanism, right? We discussed about density, the relative density, and all types of pressure. All types of pressure. That means normal. What's the meaning of pressure? I told pressure mean the force perpendicular force exerted on a unit area. The perpendicular force exerted on a unit area, right? That's the pressure. Then we discussed about hydraulic pressure. Hydraulic pressure. What's the meaning of hydraulic pressure? The pressure of any point inside any liquid, in whatever liquid, right? Water, oil, or whatever. The pressure exerted on a point in a liquid that we call as hydraulic pressure. Hydraulic pressure. How to get the hydraulic pressure? H rho G. I think you can remember there are three main factors affect on hydraulic pressure: height, the density of liquid, and the gravitational acceleration. H rho G. H rho G, right? H rho G is the hydraulic pressure. Hydraulic pressure. Then finally we discussed about atmospheric pressure. Atmospheric pressure means the pressure exerted due to the weight of atmosphere, the weight of gases in the atmosphere, right? Okay, how to measure atmospheric pressure? What is the instrument we can use to measure hydraulic pressure? Actually, not hydraulic pressure, atmospheric pressure. What's the instrument? Mercury barometer. Great. Mercury barometer is the instrument. Great, Joe. Yeah, mercury barometer, the principle and how to use. I told if you measure the atmospheric pressure in sea level, how about the level? How about the value? Kabir. What's the value at atmospheric pressure? Great. It is 76 mercury centimeter, HgCm, CmHg. Mercury centimeter 76. If you got millimeter, it is 760. Right? I told the maximum point of the Earth, that means the top of Everest. Everest ke mudune. The atmospheric pressure 18 centimeter mercury centimeter, right? Then you can understand with latitude, they can height take a very from sea level. When increase in the height, what happened? When increase in the height from the atmosphere, whatever the atmospheric pressure will be decreasing. Atmospheric pressure will be decreasing. I think the mechanism of barometer, that was exam question. I already explained and I gave a note, everything. And I mathematically I explained why we can't use water as a fluid, right? As a liquid of the barometer. I think you can remember. Okay, do you have any doubt up to now? Because today we're going to discuss the most important principles. Before that, you should have basic full idea about this previous part. Otherwise, it will be difficult to understand these very important principles. Okay. Do you have any doubt up to this point? Do you remember the mechanism of barometer? The mechanism of barometer? Joel? No doubts, right? The mechanism of barometer is done. The working principle of barometer? Yeah. Any doubt? Do I need to explain again? Tanya? Dihini? Fatima? Any doubt? No. Okay, if you want, I'll within 1 minute I will explain the working principle of mercury barometer, because that will be very important for your exam. How about today exam? It's easy, right? It's easy, I hope. Fatima, what happened? Was it all? What happened? Samia, what happened exam? Kabir? Hari. Okay, I'll explain the mechanism of barometer. General, which recording you want? Which one? This one. මේක ඕනේ කලින් එකද? Previous one. මේ okay. I'll send it. Hari. Come to lesson. Barometer. Barometer is made by mercury. Okay, this is a mechanism. This is a working mechanism of barometer. The barometer contain this is a container. It's a mercury container, right? This mercury container filled with mercury, right? It's mercury. Then and we need 1 meter glass tube, 1 meter height glass tube completely filled with mercury, and we can place this glass tube like this. It's completely filled with mercury, right? Okay, now this glass tube and container both filled with mercury, right? Then what happened due to the gravity? This is an open surface. This container, this is open surface. It affects atmospheric pressure exerted on the surface. Atmospheric pressure, right? Now what happened? If you place this glass tube downward in the container, අනිත් පැත්තට හරවලා යටි පැත්තට හරවලා තියන්නේ, then what happened? This mercury, due to the gravity force, this mercury try to come out from this glass tube. මෙහෙට එන්න බලනවා. හරි. Now then we can see the mercury level is gradually decreasing. Mercury level is gradually decreasing. The mercury level is gradually decreasing, right? The mercury level is gradually decreasing. It's 1 meter is a height. Then we can see it's come to 99, 98, 95, 93, 90. That's gradually decreasing, right? But at a certain level, due to this atmospheric pressure, due to this exerted atmospheric pressure on this liquid, this weight given pressure and atmospheric pressure will be same, equal. At that level, this water level will be stopping. That value, this stopping water level value, we can get as the atmospheric pressure in mercury centimeters. At sea level, this value is 76 centimeter. At sea level, I told if you went to the top of Everest, it's the highest point. It's sometimes 18 to 20. I became 18 centimeters. Then you can see that depend on the atmospheric pressure. This exerted pressure from the atmospheric pressure, atmosphere, right? Understood? That's the mechanism of mercury barometer. You know, clear? Okay. Then the pressure completed, hydraulic pressure completed, atmospheric pressure completed. If you have complete knowledge about pressure, now we can discuss the Pascal's theorem. Pascal's theorem. Come to lesson. The Pascal's principle about pressure transmission. Okay, think this Pascal's theorem very simply you can understand, right? Pascal's theorem. Pascal's theorem. Okay, simply understand. It's a very simple story. Okay, think we have a container, right? Pascal's theorem mean it's very simple story. It's a container. Think it's a metal cylinder, right? It's a closed metal cylinder completely filled with whatever liquid. Liquid mean water water or oil or whatever, right? It's completely filled with mercury. It's a closed cylinder, right? It's a closed cylinder, closed container, container completely filled with liquid. Completely filled with liquids. Do you remember in the first day I explained fluids mainly two types. What are the two types? Compressible fluids and incompressible fluid. Compressible mean when we apply external force, external pressure, the volume will be changing. Gas is a compressible fluid. අපි compress කරලා volume එක change කරන්න පුළුවන්. Therefore that we call as compressible fluid. But liquids are incompressible fluid. For this experiment we have to use incompressible fluid. ඒ කියන්නේ liquid එකක් තමයි ගන්න ඕනේ. gas වලින් make කරන්න බෑ. හරිද? Gas we can't use because gas is a compressible. With pressure, the volume will be changed. Right? Now it is a it's a closed container, completely sealed container, completely filled with incompressible fluid. Incompressible fluid means you already know it's a liquid, right? Incompressible fluid. Incompressible fluid. Think very simple. Okay, it's just a container. Container it's completely filled with liquid and the container is now closed. Container is closed. Okay, Pascal is a scientist. He explained if I apply any external force on this, any point on this container, if I apply an external force on any closed container completely filled with incompressible fluid, මෙන්න මේ වගේ container එකකට if I applied force, it's exerting pressure, right? It's exerting pressure. Think it is PA, right? This pressure uniformly distribute throughout the liquid and throughout the container. That's a Pascal's theorem. That means අපි දැන් මෙන්න මෙතන pressure එක ගත්තත් that one also PA. If you got this point pressure PA, this point pressure PA, this point pressure PA, this point pressure PA, this point PA. That's a story. That's a Pascal's theorem. If I apply any external pressure on completely closed container, completely filled with incompressible fluid. Closed container, if completely filled with incompressible fluid, the external pressure given on any point, it's uniformly distributed throughout the container and throughout the liquid. I got අපි මේ එක තැනකට දෙන pressure එක, it is uniformly, equally, same pressure distributed throughout the container and throughout the liquid. Udanna? Understood? Okay, that's a simple way, not the simple way, actual story, complete story of Pascal's theorem. මේක තමයි ආ හොයාගත්තේ. අපි understood? Send me update, otherwise we will take more time. Because today I hope to discuss the all theories. We have 5 theories. At least if we can complete 4 theories, then Friday we can complete the lesson. Friday complete the lesson, and then next week we can discuss questions. This is the first week, ne? Yeah, this is first week, right? This is June. Third, ne? Then next Wednesday we can start the next lesson. Beginning? Clear? Tanya? Understood? If we apply external pressure of any completely closed and completely filled with incompressible fluid, if we apply external force on this type container, it's uniformly distributed throughout the container and throughout the liquid. Okay, this is the fluid Pascal's theorem. The pressure applied on an enclosed fluid will be transmitted without any change. Without any change means same pressure distribute, right? The pressure applied to an enclosed means closed, right? Seal karapu fluid will be transmitted without any change in magnitude to every point of the fluid and the walls of the container. I got? Okay, if you want, you can draw this diagram. Can you mark this diagram on your tute? Okay, that is a fluid mechanism story. Pascal's theorem story. If we apply external force, if we apply external pressure on any closed container completely filled with incompressible fluid, right? Incompressible fluid, it will be distributed without any magnitude change. It's uniformly distributed throughout the container and throughout the fluid. Note correct? Note down. Complete, Joel? Amina? I got? Yenul? Tirna? Understood? Okay, complete, right? Okay, now think about the application of fluid Pascal's theorem. Okay, do you know the hydraulic jacks all are made by according to this Pascal's theorem. According to this Pascal's theorem, right? Okay, think this is a the simple hydraulic jack. Okay, think it is a hydraulic jack, right? Now it has two pistons, small piston and large piston. Small piston and large piston. Pistons and two cylinder, and it's an enclosed container. Enclosed container means completely sealed container, right? Now fluid brake system also this same mechanism I will explain later. The fluid brakes, not only that, lot of applications. What is the main advantage of this Pascal's theorem? Application of Pascal's theorem, what is the main advantage? The main advantage, applying a small force, අපිට පොඩි force එකක් දීලා we can do more work. We can generate huge force. We can generate huge force by a small force, right? Well, okay. Okay, this is the two pistons, and it's completely filled with incompressible fluid. අපි මොනවද දාන්නේ මේ jack එකට? It's filled with oil, no? Why we can't use water? Water also liquid. Yeah, last day I explained. Water density is very low. Then we can't make this hydraulic jack in compacted way. Water use karut, there are so many problems I will explain later. Water has low density compared to oil. Oil, they large, heavy density, no? Think this is a point A. This is a piston. This is a B piston. Think the cross section area of A piston 5 square centimeter. The cross section area of B piston large one 50 square centimeter. 50 square centimeter. Now 5 Newton external force, 5 Newton, very small force applied on the small piston, right? 5 Newton external force applied on the small external force applied on the piston A, right? Then we can get the pressure exerted on A piston. Pressure on A piston. Okay, how to get the pressure? Perpendicular force divided by cross section area. Perpendicular force divided by cross section area. The perpendicular force 5 Newton. Cross section area 5 square centimeter. 5 square centimeter. But square centimeter you have to convert into square meters. How to convert? 5 square centimeter divide by 100. Again divide by 100. Then it is converted to square meter. Up value will come 5 into 10,000 over 5. Then 5 to 5 cancel out. 10,000 Pascal. 10,000 Pascal exerted on the A piston. 10,000 Pascal exerted on the piston now. Piston A. Right? Piston A. 10,000 Pascal. Or 10 kilopascal. Right? 10 kilopascal. Okay. Next, the pressure exerted on piston B. Pressure on piston B, pressure equal F over A, right? F over A. Now you already know the pressure exerted on B equal, it's an enclosed system. Then not only A and B, every points, what happened? The same pressure is exerted, right? Then B point also same pressure exerted. B වලත් එකම pressure එක තමයි exerted වෙන්නේ. Then the pressure equal 10,000 equal F don't know, cross section area 50 divided by 100 into 100. Why I convert into why I divide by 100 into 100 to convert into square meter, right? Then cross multiplication, F equal 10,000 into 50 divided by 10,000. Now 10,000 to 10,000 cancel out. F equal, the force equal 50 Newton. 50 Newton. Okay. I got, by applying 5 Newton, we can increase that force up to 50 Newton by this system, by this hydraulic jack, according to Pascal's theorem, according to the application of Pascal's theorem, right? 5 Newton small force, we can, applying 5 Newton external force, we can get output 50 Newton external force. That's how all they are the applications. Hydraulic jacks and they are the applications, right? Hydraulic jacks, fluid brake systems, fluid pressure jacks, hoist used to lifting vehicles. Hoist mean the same mechanism, right? Hoist are service to heavy vehicles like backhoe and JCB. Yeah, there are levers working according to this Pascal's principle. By giving a small external force, we can get large force as the output of the container, right? That's the applications of Pascal's theorem. Understood? Understood? Dihini? Okay. Then according to Pascal's theorem මෙහෙම පුළුවන් නේද මට කියන්න. According to Pascal's theorem, right? බලන්න. Okay, according to Pascal's theorem, theory, point A, that means any point pressure of point A, PA equal to PB, right? Pressure of A point equal to pressure of B point. Then I can get a relationship A point pressure F1 divided by A1 equal to F2 divided by FA2. Okay, that's a short method to get the for our easy calculation. F1 over A1 equal F2 over A2. But for you apply this mechanism, you have to remember it should be a enclosed system and completely filled with incompressible fluid. Okay. Okay. Note down this. The equation already given. The equation already given. Yes. P1 equal to P2. P1 equal to P2. Then F1 over A1 equal F2 over A2 is the equation. Okay, if you want this calculation also, you can note down. This part is given. The right side part is given. If you want, you can note down this part. Okay, now let's do an exam question. It's a simple exam question, right? It's a hydraulic jack with 2 pistons. මෙතන oil එකක් තියෙන. It's completely filled with oil and small piston radius 10 centimeter. Sorry, 1 centimeter. 1 centimeter radius. Large piston radius 10 centimeter. 10 centimeter radius. Okay, if you want to obtain 500 Newton external force on this as output. What is the input force required? What is the F? හරි ඉක්මනට හදලා කියන්න. What is the input force requirement? කොච්චර force එකක් දෙන්න ඕනේද? Okay, quickly calculate. That was exam question. To obtain 500 Newton external force, what is the input force requirement on this system? Use Pascal's theorem. Okay, send your answers quickly. Don't take time, because then we have Archimedes principle, Bernoulli's principle, continuity principle, lot of principles, and floating mechanisms, right? Habir? To get 500 Newton output, what is the input force requirement? Yeah, others? Yeah. No, Udanya. Check again. Okay, let's. Okay, the pressure exerted on the small, that mean simple equation F1A1 equal to F2A2, right? Then FA we don't, sorry, F1 we don't know. A1 phi r squared, because it's a circle, right? The cross section is a circle. Phi into r squared. R squared mean 1 into 1. No need to convert into meter because cancel out. මේ පැත්තෙත් අපි centimeters වලින් දාන්නේ. F2 500 5 into 10 into 10. Right? Now F1 divide, now 5 to 5 cancel. over 1 equal 500 over 100. Sorry, then correct. Then 500 to 2020 cancel. Then F1 equal 5 Newton. Others are wrong. What happened? Kabir, Dihini, you all are wrong. The area, not area is 10, the radius is a 10. Kabir, I got the radius is a 10, then you have to calculate the area. You have to calculate the area. Dihini? Not 50. Yeah, then correct. Good. By applying 5 Newton external force, we can get output 500 Newton external force, right? Amina? Ajol, not 50. 5. Okay, you have to careful. Always pressure is not force into radius. Force divided by radius. Force divided by area is the pressure, right? Joel, clear? Dihini? Now okay? Hurry. Okay, let's move into next part, the upthrust. Do you know upthrust mean if we immersed any substance or any object in a liquid, mainly, right? Liquid. Think it's a liquid in a container. In this part, we mainly discussing about static fluid. Static fluid. Fluid in a container, right? Not moving. Dynamic fluids we can discuss later, right? Now, if any substance object, if it is completely or partially or completely immersed in water or whatever this liquid, the force is exerted upward by the liquid. Okay, this force we called as the upthrust force, right? Upthrust is a force which push out upwards on an object submerged in a fluid. If any object submerged in a fluid, the force exerted upward on this, upward by the liquid, upwards by the liquid. Okay, this is an experiment we can conduct to understand the upthrust force. Okay, then the first step, I think it's a very simple experiment you have already done in O-level time. There's first we can measure the weight of any object at atmosphere, right? Atmosphere. Then we can submerge in a liquid, then measure the weight, right? The weight difference is the upthrust force. Why it is coming pressure difference? Due to the force exerted upward to the object by the liquid, right? Then this is upthrust force. This is upthrust force. Then we can get the W2. See, W1 is greater than the W2. The reason is upthrust force. Then we can say upthrust force equal upthrust force equal W2 minus W1. Sorry, W1 minus W2. W1 minus W2. Right? As example, think in atmosphere it is 10 Newton, weight 10 Newton. If it is submerged, after submerged in fluid liquid, it is 8 Newton weight, W2, then upthrust force equal 2 Newton, right? Upthrust 2 Newton, right? Okay, that's the story. That's a story. That's a story. Write down here. U equal W1 minus W2. U equal W1 minus W2. Example, U equal 10 minus 8. U equal 2 Newton. That's the upthrust force, right? Upthrust force. Okay, note down. Upthrust force. If any object submerged complete or partially in any liquid, the force exerted upwards by the liquid again upward in a force, right? That we called as upthrust force, right? Okay, the Archimedes principle is our next principle. Archimedes also, he is a scientist who explained about the relationship between upthrust force and the upthrust force. Sorry. Okay, Archimedes principle. Archimedes also a scientist explained the relationship between weight and upthrust force, right? Weight and upthrust force and any object. Okay, this is the Archimedes principle. Archimedes principle. That's one also very simple. Archimedes principle, right? She explained about very simple experiment. Archimedes also explained about very simple experiment. I think it is a now it's a container, right? Container. This one called as displaced container. අපි මේකට කියනවා displaced container එකකි. Right, with some output hole. And this is a water level now. Fill water up to this level. Fill water up to this level, right? Fill water up to this level. This is water now. And we can place a container here to collect displaced water. Okay, now think it is water. The water filled up to displaced point. The water filled up to displaced point. Now we can submerge particular object in this liquid, right? Submerge. Up make a gillano, right? Submerge whatever particular object in this liquid. Then what happened? Part of water, according to the volume, according to submerged volume, the extra water will be displaced into the out of the displaced container. මෙතනින් ටිකක් displace වෙනවා. Right? After submerge, some part of liquid will be displaced from this container. Right? If we measure the weight of, if we using triple beam balance or electronic balance, if you measure the weight of this liquid, it is equal to the upthrust force. It is equal to the upthrust force act on this object. Right? Act on this object by the liquid. Act on this object by the liquid. I got? That's a simple theory. If any object completely or partially submerged in the liquid, the weight of displaced liquid amount equal to the upthrust force act on the object. Right? That means upthrust force equal to the weight of the displaced liquid. Upthrust force equal to the weight of the liquid, weight of the displaced water. I got? That is a simple Archimedes theorem. When an object is completely or partially immersed in a static fluid, static fluid, that means in a container, right? The upward thrust, that means upward force exerted by the fluid on object is equal to the weight of the volume of fluid displaced by the object. Can you understand? Do you have any doubt? When an object completely or partially immersed in a static fluid, the upward thrust, that means upward force, equal to the weight of the displaced water, weight of the displaced fluid. Understood? Then we can say upward force, that means U equal to the weight of displaced liquid. Clear? Tanya? Understood? The upthrust force equal to the weight of the displaced liquid. Upthrust force equal to the weight of the displaced fluid or liquid. Okay, that is the Archimedes principle. Archimedes principle. That's the Archimedes principle. Okay, any doubt up to now? Yenul, Kabir, Fatima, Tanya? Any doubt? Archimedes principle done, right? Archimedes principle mean if any object completely or partially immersed in a liquid, the upthrust force equal to the weight of the displaced liquid by the object. The weight upthrust force equal to the weight of the displaced liquid by the object. Object again displace karna liquid amount again weight ekata equal වෙනවා upthrust force එක. Right? According to that, we can get very simple equation. Now you can see upthrust force equal to the weight of liquid, right? This weight of liquid we can write in U equal rho mean density of the liquid, V mean the volume, and G, remember you have to remember two equations on Archimedes principle, uppress force equal to the weight of the displaced water, then it is same U equal rho Vg. Remember, rho U equal uppress force equal rho Vg. Rho Vg also make a thumb. Rho mean density of liquid, V mean volume, G mean gravitational acceleration. Then U equal rho Vg is the equation. That is the complete Archimedes theorem. That's the Archimedes theorem. Then you have two equations. Uppress force equal to the weight of displaced water, displaced liquid. The weight of liquid, the weight of displaced liquid, we can express as rho Vg. Rho means the density of this particular liquid. V means displaced volume multiplied by gravitational acceleration. Right? Right. I think make a now you know density equal M over V ne. ඒ ටික තේරෙනවා කියලා මම හිතනවා ඒවර ඕනේ density equal M over V, right? Then I want M equal dV ne. D වලට මම it's a liquid, therefore I can get rho V. මෙයා මම rho කියලාම දාන්නම්. Rho equal M over V. Then M equal rho V. Rho V mean M into G is the weight, right? Rho V G. Rho V G equal to weight. Weight equal mg. Mg mean weight equal rho V G. Hari, Tanya, understood? Rho V G is the density of liquid, volume of liquid into gravitational acceleration, right? It is the uppress force. Udanya, Tema, Amina. That is very, very important. That's why I again ask. Joel, Abir, you know. Okay, next point. For an object to remain buoyant in a liquid, buoyant mean, I will explain later, buoyant parts, meaning of buoyant. The weight must be equal to the upward thrust. Yeah, that's true. I will explain that later in the floating part. If the mass of the object is mn, mean density is rho. It is not P, sorry, it's rho. And volume is V. If it is volume V, we can say uppress force equal rho Vg. Remember that. Rho Vg. Hari, that you already know. Hari. Okay. Okay. Now, we have another part, the most important part. Okay, if you got any liquid, static liquid in a container, right? Static liquid in a container. Static liquid in a container, right? the water is filled up to this level. Now think object A partially submerged in the liquid, partially submerged. Object B completely submerged, but it is floating, still floating, still floating. Object C completely sinking up to bottom, right? Okay, think if any object floating on the water or on any liquid, floating, or floating mean අපි කියන මේක partially immersed, partially submerged in the water, partially submerged in liquid. Think this is the mass of the object, mass. Its relative density. That's the usage of relative density. This object, think it is A, B, and C, right? A, B, and C. A relative density අපි දාමු එයා D කියලා. Its relative density, whatever object density, right? Density mean mass over volume, right? Mass over volume. Its density, right? Its density less than the fluid density. Its density less than the fluid density. That's why it is floating. That's why it is floating. And its upthrust force is like this. Its upthrust force is equal to the weight. Upthrust force is equal to the weight. Weight mean mg, right? මෙහෙම දාන්න mg කියලා. mg mean u equal to the rho vg. U equal to the rho vg. Rho equal to the rho vg, right? Okay, that's how any object is floating, partially submerged in the liquid. Upthrust force equal to the density. Sorry, upthrust force equal to the weight of the object due to the object density is less than the liquid density, right? Object density less මෙයා අඩුයි than liquid density, right? Think liquid density is the rho, right? Object density D, simple D, right? හරි, අපි B ගැන ගාලමු. Let's think about B. Okay, what's the story of B? මෙන්න බලන්න. What's the story of B? Now, object density, particular object density, B object density equal to the rho, equal to the volume density of the liquid, and that one also floating, right? Both floating mean u equal to mg. U equal to mg mean u equal to rho vg. U equal to rho g. U equal to rho vg. That already given. That's already given, right? U equal to rho vg. Understood? If you got C, it's completely sink up to bottom. The reason is the object density mean B greater than the liquid density. Object density is greater than the liquid density, right? And object density is greater than the liquid density, and it yeah, upthrust force, not upthrust force, yeah, upthrust force less than the manipata dhanam mg mean weight greater than the u, and mg weight is greater than the upthrust force, that's why it's sinking, right? That's the reason for sinking. uh, Samely rho vg greater than the u, vg greater than the u. Okay, that's the story. That's how any object floating decide floating or sinking. Float when hari, sink when hari, due to these characteristics. Okay, if you want, you can note down. However, it is already given in the tube. Okay, Sarmia, clear up to now? Okay, then what is the requirement to float any object? What are the float when? What is the requirement? The object density less than the fluid density, right? Liquid density. That is a requirement. That's a requirement. For next part, that will be very important. Object density less than the liquid density. D less than the rho. Understood? Dihini? Tanya? We got? If any object need to be floated in liquid, in a whatever liquid, what is the requirement? Object density less than the fluid density. If it is less than, it's floating. If it is equal, floating after submerge, middle stage. But අපිට boat එකක් ship එකක් නම් මොකද වෙන්න ඕනේ? In first stage, right? Remember that. Remember that. හරි. උදන්නා clear? Amina? Okay. Okay, complete, right? Huh. Okay, let's move into next part. That will be very important part, right? Okay, that one also very important. A solid body drops into a fluid will sink, float, or remain at rest. Remain at rest mean that midpoint, mid level. That depending on its average density relative to the density of the fluid. That's important. That depend on the average density of the object relative to the density of the fluid. Right? Then now you can understand density of the liquid. The object average density and liquid density according to average object density and liquid density. The floating, raised, mid-level or sinking depend according to the object density and the liquid density. If it is same, if it is object density and liquid density same in mid-level, if it is object density less than liquid density, it is floating. If it is object density greater than fluid density, it is sink into bottom. That's the summary, right? All right. Go to next part. Float and sink. Float and sink. Okay, now we have, now don't you have any doubt? Now think, if I think any metal cube or metal sphere, මොනවා හරි අපි metal වලින් අපි iron වලින් හැදුවොත්, think iron piece, iron block. If I place into, if I drop into water, what happens? Sinking or floating? Iron drop. Think 1 kilogram iron cube drop into water. It's sinking or floating? Beginning. Sinking or floating? 1 kilogram iron cube drop into water. Water tank. Sinking or floating? Sinking. Yeah. Now using same iron cube, if I made අපි මේ වගේ එකක් හැදුවොත් just like a container, that one also 1 kilogram. If I drop this container into water, sinking or floating? Sinking or floating? Same iron cube, 1 kilogram. Amina, what do you think? If I drop this one into water, sinking or floating? Tanya, it is sinking or floating? Yeah, it is floating. What is the reason? Same iron block, 1 kilogram, both 1 kilogram. Joel, what is the reason? Why it will 1 kilogram iron block is sinking, but 1 kilogram container floating? What's the reason? What's the reason? No, area is not the reason. No. Area is not the reason. Area එක නෙවෙයි. Yeah, volume is the reason. The volume is the reason. මේ බලන්න. Very, very important part. Lot of exam questions based on this part. හොඳට බලන්න. Think, right? Now, the density of any object equal to the mass divided by volume. Mass divided by volume. In the first part, I explained that density means the amount of matter in a unit volume. That means mass in a unit volume, right? When increasing the volume, of the object, what happened to the density? Density is gradually decreasing. Density decreasing. It is inversely proportional. inversely proportion. Now think it is water density 1000 kilograms per cubic meter. This is the water density, right? Water density 1000. Now think iron cube density 1200 kgm minus 3, but water 1000. That's why it is sinking. That's why it is sinking. But if we convert that same iron block, if you convert melted and convert into block iron contain එකක් හැදුවම, then what happen? It has higher volume comparative, like, right? It has higher volume. Then same mass, 1 kilogram, higher volume. Then what happened to the density? Its average density will be decreasing up to 900 kgm minus 3. That's why this object floating. That's why, that's the reason if you iron cube, if I drop iron cube into water, it's sinking, but more than 15 to 100 tons large ships are floating on the water due to this mechanism. Due to this mechanism. I got? Due to this mechanism. Understood? 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 Udanya? All boats, ships, everything made according to the principle of the water density and object density variation, right? Always boats and ships made with low density, average density, by increasing the volume. Increasing the volume always අපි water density වලට වඩා අඩු කරොත් average density එක definitely it will be floating. තේරුණා? Joel? Dihini? Okay, I will explain a story about ships. Ships loading. It's an empty ship. It is a loaded ship. Loaded ship. Do you know, while loading, අපි load කරද්දී ship එකකට load කරද්දී we have to more careful. Why? Why? In the loading process, what happened? The mass is increasing. Mass increasing. Mass increasing mean mass එක වැඩි වෙනවා කියන්නේ මොකද වෙන්නේ? Density equal average density equal mass over volume. When increasing the mass, what happened? Density gradually increasing. අපි load කරද්දී density of the ship is gradually increasing, right? But now think if it is increase the, if this density increase than water density, what happen? Make average density of water density එකට වඩා වැඩි වුණොත් the ship will be sinking, right? Ship එක ගිලෙන්න පුළුවන්. That therefore very careful. Okay, do you know? Okay, you can search about that. It is a for additional knowledge. Normally ship එකක ships, the body of ships contain this type line. මෙන්න මෙහෙම line එකක් තියෙනවා. right? That we call as plimsoll line. Plimsoll line. You can search about that. Plimsoll line. Also, I'll show you. Plimsoll line. Plimsoll line. Normally, the loading process of ships may uh, doing according to this plimsoll line. Make a very important for our lesson. Plimsoll line. Plimsoll. Sorry, there's a connection. Give me a second, there's a connection. Yeah. There's plimsoll line. Maybe no access. Yeah. This is a plimsoll line. Maybe plimsoll line. Plimsoll line is a line. It's just like a benchmark as a reference for maybe, right? It's just a measurement of loading to a chips. Load කරද්දී use කරන measurement එක. Now think normally if it is not loading, empty shift, maybe if it is empty shift, this is the level. This is the level. මේ ගන්න තමයි sync වෙලා තියෙන්නේ. Right? But when it is loading, what happened? It's gradually sinking. මෙයා sinking වෙනවා. මෙයා ගිලෙනවා. Why? The density increasing. Due to increasing the density, when increase the mass, its density increasing. Due to that, it's sinking. Sinking up to this level, up to this level, right? This level, right? The meeting of water. Now think this is a level now, up to this level loaded. Now entire this part is water now. It's completely sink. Right? Now before loading, we have to carefully refer about the shift maps mean the flowing path maps the path of the travel, yes, the path of the travel. think it is Japan to Sri Lanka, then again China or whatever, it was America, right? Now we have to be more careful about what happened to the water density. Sometimes sea water is not 1,000 density. It is little bit greater than 1,000. Sometimes some areas of uh, sea areas, they have high density water. Sometimes it is low density water. What happen if it is completely the methanol load කරගෙන ගිහින් methanol load කරගෙන ගිහින් if it is change the water density, what happen? It is floating, therefore it is sinking. එතකොට ගිලෙන්න පුළුවන්. It is very dangerous. Okay, therefore it is an engineering work. First of all, we have to be careful about the environment condition, temperature condition, water density. ඔක්කොම බලලා තමයි loading කරන්නේ. Right? I got this plimsoll line helps to determine up to which level need to be loaded as a reference, right? As a reference. Okay, now you can understand how any object sinking or floating, right? That totally depend on the average density of the object. Average density of object relative to the liquid density. Relative to the liquid density. Now, ships, boats, everything floating in water, and therefore 1,000 or 1,100. If it is salt water, that means sea water, it is little bit greater than 1,000, right? Because salt concentration. Right. Okay, the next one is the most important one. Before that, please note down this theory. Okay, මෙහෙම ලියන්න. Object average density less than the liquid density. මෙහෙම ලියන්න මෙතෙන්ට. Then what happened? Object floating on liquid. Object floating on the liquid, right? It's just one point, right? එක point එකක් විදිහට ලියන්න. The second point, object average density. Object average density greater than the liquid density what happened? Object sinking in liquid. Object sinking in the liquid, right? Object sinking in the liquid, right? Object sinking in the liquid, right? Final point, මේකත් ලියලා තියන්න. Density equal to mass over volume. Volume increase, what happened to density? Density decreasing. Density decreasing. Inverse relationship. mass increase, density increasing. Then what is the option? If you need to increase sinking property, we have to increase the volume. Understood, Joel? We have to increase the volume of the object without mass, without increasing the mass. Again, same mass same as previous example. If we keep 1 kilogram same mass, if we increase the volume, after certain volume level, the object is start floating. Joel, clear? Others? Udanya? Okay. Not down, sorry. Complete this space. Okay, this is the basic concept need to be remembered. Amina, understood? Okay, great. Okay, then let's move into the final topic of static fluid, the buoyancy. 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 Okay, what's the meaning of this buoyancy? That we call as buoyancy point. Buoyancy point. මේක සිංහලෙන් කියන්නේ ටිකක් අමුතු නමක්. මේකට සිංහලෙන් කියන්නේ උත්ප්ලාවකතා කේන්ද්‍රය කියලා. හරි. The English name easy. The buoyancy point. Or center of buoyancy. Center of buoyancy. Okay. You know, in first lesson, I explained the weight acting point. Weight acting point of any object, that's a point of gravity, right? Gravitational point. Or point of gravity or gravitational point. Remember, the point of upthrust force acting point is the point of buoyancy or buoyancy point, right? This is a simple story. Now think, now it's a liquid. This is a liquid. This is an object. This is a weight acting point, W. That is a gravity point. Gravity point. gravitational point came, gravitational point. Now there is another force acting towards to upward that we call as upthrust force U. Upthrust force. This upthrust force acting point is the most important one. Upthrust force acting point is the buoyancy point. Buoyancy point. Buoyancy point. Buoyancy point. Okay, note down. Note down and highlight this. The point at which the upthrust force act is called as a center of buoyancy. Center of buoyancy. When an object is immersed in a fluid, the volume of fluid displaced by the considered as the solid object and its center of gravity can be called as a center of buoyancy. The upthrust force equal to the displaced water volume weight, and this upthrust force acting point is the center of buoyancy or buoyancy point. Understood? Okay, note down this one. That's center of buoyancy. And next Tuesday also you have exam, right? Now you have to continuously working, not focusing to exam but network. You have to continuous working within these 60 days. Continuous working mean you have every Tuesday you have MCQ paper and Wednesday you have essay and structured paper, right? Every week you have, and I'll give you marks within this today exam marks I will send before next Tuesday. ඒ විදිහට continue කරගෙන යන්න තියෙනවා. Every Tuesday morning you have MCQ paper, Wednesday morning you have structured essay plus essay paper. Starting from next week, right? Because now we have another 9 weeks, right? 9 weeks we have අපිට දැන් සතියට එක ගානේ කරත් we have full papers 9යි කරන්න පුළුවන් නේද? we can only complete 9 full papers. 9 full papers mean we have already now 7 exams done, right? 7 exams done mean 9 plus 7 only 16 තමයි කරන්න. Yeah. Okay, therefore to next Tuesday you have MCQ exam morning. Wednesday morning you have structured essay plus essay paper. Now because අපිට දැන් ගොඩක් papers තියෙනවා. දැන් අපි we have lot still not release any model paper or provincial papers, no? In July, the 3rd week of July, most probably releasing every provincial papers and model paper. That one also we have to complete. And last year model paper and provincial paper also we have, right? We have a lot of works. and we have a lot of past papers. I think you are working on past papers. I'm not more focusing into past papers because you have papers and answers. You can go through them. I'm focusing into other complete maximum other papers. Okay. Okay. The center of buoyancy. What's the meaning of center of buoyancy? The upthrust force acting point. Very simple. The upthrust force acting point is a center of buoyancy or buoyancy point. The weight acting point is a gravitational point that you already know, right? All right. Let's move into the next very, very important part. All right. Now, we have a practical. I think you have done this practical in all of our time, right? Okay. This is a simple practical. Now I have a water cup, right? It's a water cup. Water cup. It's a water cup and pencil. Now, if I drop this pencil into this water cup, what happened? Is it what happened? It's rotating, right? If it is stable, that stability means just like this. But you can see, if I release this, it's rotating. If I release, it's see, it's rotating. But if I release, just it's rotating, right? It's rotating, right? It's try to rotate. See, it's try to rotate, but give me a second. Okay, but now I have increased the weight. The මෙතන මම මේ object එකක් set කරලා තියෙන්නේ. Now I have increased the weight. Now you can see it's very slowly rotating now. the story rotating අපිට මයින stable කරන්න පුළුවන්. Stable, right? But still rotating. But if we can increase the bottom weight, අපිට මෙතන weight එක වැඩි කරන්න පුළුවන් නම් then it will be stable. If we can place a clay part, අපිට clay වලින් if we can increase the weight, that we can stable. Okay, what is the reason to come stable? Stability of a floating body. Stability of a floating body. Stability of a floating body. Okay, it has a complete physics. Now you can understand. Now you already know the basic concept to understand this theory, right? Now, to keep stable of any object like this, to keep stable, now if I got think it is a static fluid. Now it is static fluid. This is a fluid level, and this is a whatever object, floating object. If it is stable, what is the main character? What is the main requirement? There are only two forces. Make no any extra forces acting. Think it is weight and upthrust force. This is a gravity point G. This is G naught. Upthrust buoyancy point. Right? Now, if it is stable in a liquid like this, if it is stable, what are the main characteristics? Now, two forces acting on, in force lesson you already know, two forces acting on opposite directions and acting on a same line. If it is on two lines, it's rotating. That's why the pencil is rotating. I will explain. Right? If it is stable, the main requirement, this weight and upthrust force act on the same line. That's the main characteristic. Then think this way, in the same liquid. Now pencil example. Right? This is the weight. This is a weight. Weight always act towards the gravity. Weight. And buoyancy points also is act towards the upward. Then they have gap. This upthrust force and weight not acting on the same line. That's why it is rotating. It's rotating. I got. That's why it is turning. But it is stable. It's stable. The reason force and upthrust force act on the same line. But if it is act on different lines, that we call as couple of force. Couple of force on two lines. Right? Therefore, couple of force always turning. Understood? It's not stable. Understood? If you want, you can note down. This is stable when made in act on same line. If it is unstable, these are a couple of force. Kabir, clear? Fatima? Tanya? Amina, understood? Amina, Udanna, could you understood? Could you get this? Yes. Tanya, what happened? Okay, let's move into next one. Final point, right? Yeah, rotating couple. This is unstable. This is a stable, right? This is a stable. This is stable. Now, this one very important. When we are important. Now think. Now think. This is the water level. This is a water level. This is a floating object. This is a floating stable object. Floating stable object. For me, weight and buoyancy point act on same line. Hari. මෙයත් හිතන්න this object also floating object act on same line. Act on same line. Hari. Hari. මෙන්න මෙයාගේ this is the weight. This is the weight. And this is the මෙතන this is the upthrust force, right? Very important point. This is the buoyancy point. Buoyancy point. This is the gravity point. Gravity point. The most important one. Now it is no any problem. It is stable, right? It is stable. It is stable. The same way. This is a gravity. This is the weight. This is the weight. This is the buoyancy point. This is upthrust force. This is the buoyancy point. This is a gravity point. Okay, what is the main difference? What's the main difference? What's the main difference among the two floating objects, Tanya? What's the main difference? What the වෙනස? හරි. බලන්න. For this type object, now it is no problem. It is stable, no rotating, no couple of force, upthrust force and weight act on same line. Become එකම line එකේ, therefore stable. But if there are any disturbance, ඒ කියන්නේ disturbance එකක් එනකන් okay. ඒ කියන්නේ මේක හුලඟක් ආවා කියලා හිතන්න. Due to wind or whatever disturbance, due to water wave, whatever reason, if it is rotate, if it is change the position, මෙයා චුට්ටක් rotate වුණොත්, it is continuously rotating. The reason, the buoyancy point lower than the gravity point. Buoyancy point එක යට තියෙන්නේ මේ. Buoyancy point greater, lower than the gravity point. Now think second object, it's no any problem. Gravity point is lower than the buoyancy point, no any problem. If there are any disturbance, again it's come to the original position. Understood? Understood? If we release after rotating, again it's come to the original position. I got. Then if it is permanent stability, that we call as temporary stability. Temporary stability, right? That is permanent stability. Then you have to remember, if it is permanent stability, the gravity point should be lower than the buoyancy point. Then if it is any disturbance, again come to the original position. Understood? Stability means both stable, not rotating like this, not couple of force, but both stable, no problem. But if there are any disturbance, this one again come to the same position. But this temporary stability one not again come to the original position. Again it's continue rotating. Rotatela vaten. Hari. Understood? Then Joel, Kabir, Fatima. Clearly note down, right? Clearly note down. Clearly note down. Stability mean if it is gravity. No. Continuous rotating mean एक මෙහෙම stable නෑ. Continuous rotating කියන්නේ මෙහෙම දිගටම rotate වෙන්නේ නෑ. Just rotating. Rotating කියන්නේ මෙහෙම හැරෙනවා කියන එක. ඒ කියන්නේ pencil එක වගේ. Just pencil. Okay, Joel? It's not continuous මෙහෙම rotate වෙන්නේ නෑ. Just මෙහෙම තියෙන්න ඕන එක. If there any disturbance, it's come to this way. But permanent stable one, if there are any disturbance, again come to original position, right? The reason gravity point lower than the buoyancy point. That was exam question. Exam එක අහලා තියෙනවා. Now come to pencil example. In our pencil example, why it is rotating, it is not stable. Not stable mean buoyancy point buoyancy point lower than the gravity point. That's why. Okay, but if we can increase the weight, අපි මෙතෙන්ට මොනවා හරි set කරලා if we can increase the weight, we can keep stable like this. මෙන්න මෙහෙම තියන්න පුළුවන්. If we can keep stable like this, right? Keep stable. Then the gravity point lower than the buoyancy point. Now it is unstable, right? Unstable. Okay, that's a lesson. Okay, that's the final part of this static fluid part. To measure the density of any liquid, we use hydrometer or lactometer. lactometer. Lactometer means it is mainly used for measure the density of milk. That's why we call it as lactometer. However, any fluid we can measure the density by hydrometer. That means lactometer tama name එක. හරි? Lactometer. The condition of milk or liquid being tested can be understood by the amount of sinking. That means we can measure the density according to the amount of sinking in this liquid. Okay. Okay. There are a lot of things you need to understand this lactometer. This is the shape of lactometer. This is the shape of lactometer. I'll get some diagrams to explain the lactometer. That was exam question one time, therefore important. Lactometer. Okay, they are the lactometers. Wait, I'll take. Okay, this is a lactometer. Okay, what are the parts of this lactometer? Lactometer, you can see it has a thick body part, right? Thick body part with high diameter and very thin tube, right? Thin tube, and it has a metal balls. At the bottom, we have to add some kind of metal balls. ටිකක් දාන්න ඕන. What's the purpose? To increase the weight, right? To increase the weight. Okay, everyone has a reason, right? Okay, they are the main parts. It has a thick body and very thin tube, capillary tube, and metal balls. Okay, what's the purpose of adding metal balls? That was the exam question. What's the purpose of adding metal ball? What's the purpose of thick body? And what's the purpose of thin tube? Okay, remember that. Okay, how to measure the density using this lactometer? After we adding into a whatever liquid, think this is a liquid milk, sample of milk, we can place the lactometer inside this liquid, right? Place the lactometer. We have to add in a test tube, right? Test tube. Right? This is a milk sample. Then we can, this is a lactometer. Lactometer එක මේකට දානවා. This is a lactometer. according to this sinking level, we can get the measurement, right? We can get the measurement. Metana thiyena value is the density of this milk sample or whatever liquid. Okay, what's the purpose of the metal ball? What's the purpose of this metal ball? Remember that the metal ball purpose increase the weight. Increase the weight and remember, note down that increase the weight and increase the weight and get gravity point lower. Gravity point get into lower end. That's the purpose. Then we can keep stable this. If it is rotating, we can't get measurements. It's completely stable. මෙහෙම අපි වතුර එකට දැම්මම මෙහෙම තියෙනවා stable. Right? Understood? That we doing by metal balls. Increase the weight and get the then make මෙහෙම තියෙන. This is a buoyancy point upward. This is a buoyancy point. This is a gravity point. Right? That's why it is stable. Understood? This is a buoyancy point. This is a gravity point. Understood? Right. Then what's the purpose of thick body? මෙතන body එකක් දාලා තියන්නේ ඇයි? With large diameter. Thick body. Remember the reason. Increase upthrust. Increase upthrust. Increase upthrust and get buoyancy point upward. Get buoyancy point upward. Buoyancy point එක උඩට ගන්න. To get the buoyancy point upward. If we use very thin line, thin body continuous, we can't get upthrust force upward, buoyancy point upward. Otherwise, it is a problem to stability. It's a problem to stability. Understood, Tanya? Sarmya? Then what's the purpose of at the end adding a thin capillary tube? Remember the purpose to get measurements accurately. To get measurement accurately. To get measurements accurately. To get measurements accurately. Okay, that's the story. Now tell me, if this lactometer is sinking more, godak submerged venom. If it is submerging more, what's the meaning? It is high density or low density? It is low density. It's low density. Okay, now you can see the zero is there. Make a values pen now. Zero. The value is calibrated like this. 0, 10, 20, 30, 40, 50. This range can be changed according to the type of lactometer. Okay, this is the range. This is the calibration. Then if it is sinking more, the density low, right? If it is partially density, if it is partially sinking, very small level sinking, then it is high density solution. Understood? එතකොට මේ හරිය measurement එකක් නෙන්නේ. I got if it is more sinking way, the measurement coming in this level. Understood? Always calibrated upward to downward increasing, right? Downward has high values. මෙහෙ තමයි වැඩිපුර values, මේ large values තියෙන්නේ. Understood? That's the story of lactometer. If you have any doubt, please ask. Joel, understood? Kabir, Fatima? Okay, they all are exam question. Exam में क्या हाल थिब्बा? What's the purpose of adding metal balls? What's the purpose of thick body? What's the purpose of thin tube? And how about the calibration method? If it is sinking more, it's low density solution or less high density solution. If it is sinking more, it is low density solution. If it is partially sinking, half sinking, it is high density solution. Okay. Any doubt? That's the end of static fluids. Static fluid is completed. Kabir, understood? Amina? Udanya? Fatima? Okay, then that's the end of static fluids. That's the end of static fluids. That's the end of static fluid. And that's the story of see, if it is sinking low level, it's high density. If it is highly sinking, it's low density, right? It is given, right? Then our Friday lesson is a fluid dynamics. Anyone don't miss Friday lesson because we're doing very new section for you because everyone don't know in all the well time fluid dynamics, but up to now you're learning something, some parts in all level time, right? In static fluids, but the fluid dynamic is a very new section. Okay, let's start Friday evening. No doubts, right? Right. Okay, goodbye, good night.